You're welcome at Medical Sciences, where we discuss basically sciences. And we are always obliged to have you on our channel. So today we want to look at fibrinolysis. And that is what we call breakdown of the clot. We remember during secondary hemostasis, we have formed the fibrin mesh in the blood vessel. And this fibrin mesh which has been formed, it is not good to remain within the blood vessel. It can occlude the small vessels. So there is a need to have a balance between clotting and breaking down the clot so that we can exclude clots that are formed when there is an injury. So in this session, we want to look at how can we break down this fibrin mesh which is formed by primary hemostasis and secondary hemostasis. And that is what we are calling fibrinolysis. So what is the fibrinolysis? Fibrinolysis is the breakdown. Is the breakdown of fibrin, which we are breaking down fibrin mesh, which we call a clot, from the blood, so that it can be cleared from the blood vessels. So we are going to see different compounds that participate in the breaking down of the clot. And when there is a clot which is formed at the site of injury, this clot, after it has happened, alongside it there is a complex, a protein complex, and this protein complex is known as a thrombomodule. This one we call it thrombomodule. And this thrombomodulin is going to bind together with another protein known as thrombin to form thrombin complex. So these two, they form what we call thrombin complex. And it is this complex formed at the site of the injury, of the tissue injury, that is going to activate protein C. Protein C, thrombin, they are all produced by the liver. So we always have protein C which is inactive. So we are going to see that inactive protein C is activated. We form activated protein C. This was inactive. When there is no clot, it is inactive. But once a clot is formed after stopping bleeding, then it has to trigger thrombin complex, which its role is to activate protein C. And after activating protein C, this protein C does two roles. One, remember during secondary hemostasis, there is always active factor 8 and activated factor 5. So we're going to see that activated factor 8 and factor 5, they are inactivated. So one role of the protein C is to inactivate factor 8 and activated factor 5. So that is one role which it can do. The role of inactivating. So it inactivates factor 8 and factor 5. Then another thing it does, it activates, apart from inactivating factor 5, it activates tissue plasminogen activator. Tissue plasminogen activator, which we abbreviate as TPA. And this one occurs in the presence of a cofactor known as protein S. So it occurs in the presence of protein S as a cofactor. So protein S is acting as a cofactor, whereby protein C is inactivating factor 8 and activated factor 5, whereas activating tissue plasminogen factor activator. After forming TPA, which we are calling tissue plasminogen activator, this tissue plasminogen activator is the one that is responsible for converting plasminogen. This plasminogen is formed by the liver. So it is able to convert plasminogen to plasmin. So this one occurs in the presence of tissue plasminogen activator, which stimulates the conversion of plasminogen to plasmin. And this plasmin acts as a scissor. So this one acts as a scissor. It is the one that is going to go and start cutting the mesh at the injured site. Another compound apart from tissue plasminogen activator, another compound that can activate this is urokinase. Urokinase also has that property of stimulating conversion of plasminogen to plasmin. And after forming a plasmin, since it is a scissor, it is going to come on the fibrin mesh and begins removing the fibrin mesh. So this plasmin is the one that is responsible for cutting the fibrin mesh to form FDPs. Sometimes we form FDPs or we form FSPs, whereby FDPs in full they are known as fibrin degradation products. Fibrin degradation products, and these products, when the plasmin is cutting the fibrin, it first forms what we call X and Y, then later it forms D and E, dimers. So that's why we normally see that during active fibrinolysis, there is rise in D dimers. So D dimers go high. So this is a basis of test that we do to rule out DIC, that is disseminated intravascular coagulation, and ruling out DVT, that is deep vein thrombosis. That's what D dimers, which are a product of breaking down fibrin to fibrin degradation products, where we have X and Y, then later we form D and E dimers. But when we are rolling out disseminated intravascular coagulation and deep vein thrombosis, we normally dwell on determining D dimers in the lab. So in the lab, we are doing D dimers to rule out those conditions. So this is the process of fibrinolysis, whereby we have thrombomodulin thrombin complex activating protein C. Protein C inactivates, because before you break down the clot, you have to first stop the formation of the clot by inactivating activated factor 8 and factor 5. Then we are able to activate tissue plasminogen activator in the presence of protein S as a cofactor. Then another compound we can utilize is urokinase. Then we are able to convert plasminogen to plasmin, which is a scissor. And this plasmin is the one that goes and starts cutting out the fibrin mesh. And when we cut out the fibrin mesh, we form fibrin degradation products or fibrin split products, which include X and Y dimers together with the D and E dimers. But we have said in the lab we are utilizing D dimers to diagnose disseminated intravascular coagulation and deep vein thrombosis. So after seeing the stimulation of this, we can even see some compounds which inhibit the process of fibrinolysis. And one of the processes that inhibit fibrinolysis is here. At this point, we can get compounds which can inhibit tissue plasminogen activator. And this step is inhibited by a compound known as here plasminogen is PA1 and 2. So plasminogen activator inhibitor 1 and 2 is responsible for inhibiting tissue plasminogen activator from converting plasminogen to plasmin. So this process of converting plasminogen to plasmin is inhibited by plasmin activator inhibitor type 1 and type 2. They inhibit tissue plasminogen activator or urokinase from converting plasminogen to plasmin. And another drug we can use apart from this is a tranexamic acid, or we can use streptokinase. So to increase this, apart from urokinase, we can also use streptokinase, which is a drug which is got from group B streptococcus, or what we call beta hemolytic streptococcus. They can utilize streptokinase, which also is able to activate tissue factor, tissue plasma activator, to convert plasminogen to plasmin. But if we want to inhibit, we can use, naturally in our body we have plasminogen activator inhibitor, or you can use tranexamic acid. Tranexamic acid is the drug we are using in pharmacy to treat people with the problem of DIC so that we can inhibit this. So this one also inhibits. Then we have also different compounds which inhibit plasmin. For example, the plasmin inhibitors, we have alpha-2 antiplasmin, alpha-2 antiplasmin and alpha-2 macroglobulin. These two, they act by inhibiting plasmin. So when they come and inhibit plasmin, this plasmin is not able to come and start breaking down the fibrin clot. So those are alpha-2 antiplasmin and alpha-2 macroglobulin. But another thing, there is another enzyme known as TAF. This is, in full, it is written as thrombin. But here, if we have thrombin, thrombin is used to produce TAF. And the name, the in full of TAF is thrombin activatable. Thrombin activatable fibrinolysis inhibitor. So this is responsible, this TAF is responsible for inhibiting the formation of FDPs. So for it, it inhibits the formation of FDPs by stopping the conversion of fibrin to fibrin degradation products. So these are the inhibitors of this process, whereby the inhibitors, we have seen plasminogen activator inhibitor type 1 and type 2, which inhibits tissue plasmin activator, which is responsible for converting plasminogen to plasmin. As if it is not enough, we have another inhibitor, which is a drug, tranexamic acid, which can inhibit that. Then, when we have already formed the plasmin, still we can inhibit its action by using alpha-2 antiplasmin and alpha-2 macroglobulin. So we are saying the inhibitors of plasmin, we have alpha-2 antiplasmin and alpha-2 macroglobulin. These inhibit plasmin. They inhibit plasmin. That is what we are seeing. Then we have seen also TAF, that is thrombin activatable fibrinolysis inhibitor, inhibiting the conversion of fibrin to fibrin degradation products. And that is how those are the two inhibitors. So inhibitors, another one we are seeing TAF inhibiting formation of FDPs by inhibiting the degradation of fibrin to fibrin degradation products. So this is what we can discuss in this session under fibrinolysis. Please don't forget that thrombomodulin thrombin complex come into play when there is a clot after being formed, which activates protein C, and protein C inactivates these factors and activates tissue plasminogen activator at the same time as urokinase. And urokinase and tissue plasminogen activator are able to convert plasminogen to plasmin, which is a scissor, and it goes and starts cutting the bifibrin mesh, forming fibrin degradation products. Forming, that is, the first one is X and Y dimers, then D and E dimers, which we have seen can be diagonized, can be used to diagonalize this. Then we have seen the inhibitors. We have plasminogen activator inhibitor 1 and 2. We have tranexamic acid, which is also an inhibitor. Then together with alpha-2 and plasmin and microglobulin, inhibiting the scissor-like, that is plasmin. Then TAF, inhibiting the formation of FDPs. Thank you so much for learning with us at Medical Sciences. We are always proud to serve you. Hope you always gain something at their channel. Continue recommending it to many. Remember to subscribe if it is your first time. Like the video. Thank you so much.